Soaps and detergents are surfactants which clean by dissolving stains, allowing them to be removed from a surface. The basic structure of both soaps and detergents consists of a non-polar hydrocarbon tail and a polar ionic head. It's this structure that allows both soaps and detergents to function the way in which they do. And the underlying principle comes back to solubility and secondary interactions, and the idea that like dissolves like. So the non-polar hydrocarbon component of the structure is able to dissolve in or interact with non-polar substances, whilst the polar or ionic head here is able to interact with and dissolve in polar substances. Although both salts and detergents share this structure, there are slight variations between the two, which mainly comes back to the ion group present in that ionic head. In soaps, the ionic head is composed of a carboxyl ion, and the non-polar hydrocarbon chain is generally just a straight chain. In a detergent, the ionic head is a sulfonate ion. The non-polar component of a detergent also has a straight chain, but will often also include a branch and a benzene ring. The soap and detergent ions are quite often delivered as sodium salts. So you can see here we've got a sodium ion in each case that would be ionically bonded to the negatively charged oxygen in that ion. The reason they are commonly present as sodium salts is because all sodium salts are soluble in water. Therefore, when the soap or detergent goes into water, it will dissolve, releasing the ions. Soaps and detergents act as surfactants, which means they can remove our substance, our stain, the grease or oil that we're trying to remove from the surface of an object. When we're doing that, we can see we've got our surface here, we've got our grease or oil particle on the surface, which is non-polar, and then we've got our polar water up here. So what happens with our soap or detergent molecules is that they come in and the non-polar hydrocarbon tail can interact with and therefore dissolve in the non-polar grease, but the ionic head won't. So it will stay on the surface and interact with the polar water molecules. Upon agitation, this globule, which contains the grease and the soap or detergent ions, dislodges from the surface. This forms small water-soluble particles that are suspended within the water. These particles are called micelles. The reason that they are water-soluble is because of the ionic heads, which are now surrounding the surface and are able to form ion dipole bonds with the polar water molecules. And the reason they stay suspended in the water rather than clumping back together is because of the negative surface on each particle, which repels each other. So therefore, instead of clumping back together into a large grease blob that's going to settle back to the surface, they'll stay separate because the negative surfaces are repelling each other. These water-soluble micelles can now be washed away.